You know, when we think about innovation, we usually picture futuristic tech, right? But what if one of the biggest breakthroughs was happening inside a material we see literally every single day? Today, we're diving into a quiet revolution happening inside concrete, the very foundation of our modern world.
So let's really explore that. What if we could fundamentally upgrade the most used building material on the entire planet? This one question is driving a massive, yet almost invisible shift in construction. And it all starts by rethinking what holds our world together.
So here's what we've got lined up. First, we'll look at concrete's biggest weakness. Then we'll reveal the tiny innovation that's solving it. We're going to put the new method head-to-head with the old, see it in action out in the real world, and then uncover the incredible 70-year story behind it all. Finally, we'll explore why this really matters for the future.
Okay, to really get this innovation, we first have to understand the problem it's solving. Because even though concrete seems completely indestructible, it has a hidden and really critical weakness. And this slide just lays it out perfectly. If you try to squeeze concrete, it's incredibly strong. That's what we call compressive strength. But the moment you try to pull it or bend it, well, it cracks way too easily. That weakness, its low tensile strength, is the Achilles heel that engineers have been fighting against for over a century. Now, for a really long time, the solution was pretty smart. Just build a steel skeleton, rebar and mesh, right inside the concrete. The steel handles all the pulling forces that the concrete can't. And hey, it worked. But this fix came with its own, fatal flaw.
And here's the kicker. Steel rusts. Corrosion is the silent enemy that just attacks our structures from the inside out. It leads to incredibly expensive maintenance, and it ultimately shortens the life of our buildings, our bridges, everything. The industry desperately needed a better way.
And that brings us to the solution. And what's amazing is that it isn't bigger or stronger than steel. Actually, you can barely even see it. Say hello to polypropylene macrofibers. Instead of building a heavy, clunky steel cage, you just add these tiny, super strong plastic fibers right into the concrete mix. It's kind of like a secret ingredient that completely changes the recipe from the inside. I love this analogy because it's the perfect way to picture how they work. Instead of reinforcement just along a steel bar, these fibers create this incredible 3D web. It's like millions of tiny little stitches holding everything together, stopping microcracks before they even have a chance to form. All right, so we know what they are, but how do they really stack up against good old-fashioned steel? Let's put them head-to-head. This chart pretty much says it all. First, and this is the big one, plastic doesn't rust. So the corrosion problem, gone, completely. Next up, labor. It's way faster and easier to just mix in fibers than to build and tie steel cages. The reinforcement is also three-dimensional, not just directional, which makes the whole thing stronger. And finally, the carbon footprint to make these fibers is way, way lower than making steel. I mean, it's a clear win across the board. And all those performance wins, they translate directly into saving money. You're saving on materials, on heavy equipment, and especially on labor. It's not just about cutting costs. It makes the entire building process faster and a whole lot smarter. So this all sounds great in theory, right? But is anybody actually using this stuff in the real world? Oh yeah. This tech is already out there building the world that's all around us. I want you to picture those massive floors in warehouses and logistics centers that get hammered by heavy trucks all day. Or think about airport runways and parking garages that have to deal with incredible weight and brutal weather. Macrofibers are perfect for those jobs, but they're also being used in everything from the foundation of your house to precast walls and even highways. But one of the most critical applications has to be in tunneling. When you use shotcrete, which is literally just spraying concrete onto a surface, these fibers provide immediate strength the second the concrete hits the wall. For safety and speed in underground construction, that is an absolute game changer. So we've seen what this tech can do, but where on earth did it come from? Well, this was no overnight success. The story behind these fibers is actually a family legacy of innovation that goes back 70 years. It all starts back in the 1950s with a guy named Marco Terragni, a true pioneer in the European plastics industry. The tech he developed for spinning single threads of plastic, think fishing line or bristles for a brush, that's the direct ancestor of today's macrofibers. In '96, he founded a new company, Agripak, and today his children are carrying on that legacy, taking his original spinning technology and revamping it for this incredible new use. And the company at the heart of this whole story is Agripak.
They're driven by more than just this family history. They're on a mission to develop technologies that actually lower the environmental impact of industry. And these macrofibers, they're a perfect example of that. And don't think for a second this is some old, dusty technology. Agripak has combined its 70-year heritage with the absolute cutting edge. The production lines are now fully automated and fine-tuned by Cobrak.AI. That's a proprietary artificial intelligence system they built in-house to control the entire process. It's all about ensuring top quality and maximum efficiency. Okay, let's pull all of this together. We've seen the tech, the applications, the history, but what's the big picture here? Why does this shift from steel to fiber really matter to all of us? This quote just nails it. This isn't just a minor technical upgrade for concrete. It's a genuine step towards a more sustainable way of building our world, using fewer resources to create things that are designed to last much, much longer. So when you boil it all down, the takeaway is crystal clear. By just adding these tiny fibers, we get stronger buildings that last longer. We slash construction costs and labor time. We completely get rid of the rust problem. We massively lower the carbon footprint. It is simply a smarter, more efficient way to build. What's so amazing about this story is it proves that real game-changing innovation can come from transforming the materials we totally take for granted. And it leaves you with a really fascinating question. What everyday material is next?